last day, we would also see other power components like electric motor. How you can make that electric motors light, because that is also taking big weight. How we can make other power train components light. So this whole lecture is not just meant for the body in white. It is meant for the complete car, how to make it lighter. We start with the body in white. Please go on. Sorry, can you speak louder?
The AL and MG alloys into the automotive bodies.
Can you speak again?
Yeah. So as you have told that Volkswagen is currently focusing on the aluminum and MG alloys for implementing into the automotive bodies, and you are saying that we are finding the ways how we can implement. So can you elaborate something regarding the supply chain of this related alloys?
Aluminum is quite easily available from, I think, majority of the source. Novelis is a very famous source here in India. In Alcan, Alcoa, a very famous source in US and Europe. So supply is not a problem. The main problem is basically the CO2 emission during the process of the purification of aluminum. So what we are doing is mainly using recycled aluminum. So your CO2 consumption is reduced.
Okay.
Plus we are talking about aluminum of high strength steel, like aluminum 7000 series. 5000, 6000 are practically reducing. Now it is getting converted to 7000. Aluminum 7000 series has some problem with the recycling, but there are enough supplier. We will see that in the lecture on Wednesday, when I'm actually focusing on aluminum and CFK. It is a dedicated lecture on that, where I will show which areas are converted from steel to aluminum and who are the supply chain.
Okay. Yeah. And also cost variation?
Cost variation also we will see.
Okay.
And that is very important part of it. But as I told you now, initially the cost benefit was taken into advantage how much my profit is decreasing. Okay. If I am going with aluminum. Now the assumption is how much my penalty is decreasing. So no one is thinking of my profit. The cars are really not making profit. They are making profit with after sales. They are making profit with the additional services. But no car is made profit. Like the profit is practically in negative region. But now we are taking into account, okay, my penalty will decrease by so much amount, then aluminum is profitable. So that is a new trend which is coming up. Yes.
Yeah. Good afternoon, sir. Sir, actually you are worried about your penalty, but as our discussion is on lightweight material, so what about the robustness and strength of the body? As in recent case we have gone through Rishabh Pant accident and he was in Mercedes, sir. So
yes. Finally these tests are done at 60 to 50 to 60 kilometer per hour, and see the deformation. Now if you are driving at 120 kilometer per hour, nothing can help you, or more than
that. Crash test was, I think,
it's done at 50 kilometer per hour.
It normally is done at 50 kilometers, so there is no beyond range for the test.
No.
Okay. So.
But we assume that with 50 kilometers per hour, at least that assassination, inside people will not be getting damage. But finally, if you are driving at 120 or more than that, your kinetic energy is so high that no steel can withstand this. And if you would make for that special case, your car weight will exorbitantly go high. So no car maker will do it, and your EN, like your crash test is done at only 50 kilometers per hour.
So the ultimate limit is 50 kilometers.
Yes.
Okay.
Given this range of speeds, as what she said, maybe 50 kilometers per hour, is that also getting changed?
No, that is basically necessary for the 5-star crash. That at 50 kilometers per hour, if you are colliding, your driver will not be affected. The body parts will not be affected with that.
So they are going to restrict the speed also of the car when they are going to sell this vehicle?
No. The car will have same speed. In fact, you can go to 250 kilometers per hour or something like that. But the crash worthiness cannot be expected at that particular kilometer per hour. And as higher the car is, example, Mercedes itself has a problem because you have a big mass. Among all the car, Mercedes is the highest weight car. We will see lot of weight of. Now, what is kinetic energy? Half into m into v square. As the mass increases, your kinetic energy increases, and this energy is coming into that short period of time. and finally it breaks the structural part. So it is not that Mercedes was not stable, but that finally it was too much of high kinetic energy. And this is all basically also taken into that electrification of the car, because now you don't have to even just think of the person inside the car. You also have to think that the battery should not also get damaged. Because if the battery gets damaged, you will not die because of the crash, you will die because of fire. So basically, it's also important for that car should, by 50 kilometers per hour, should deform such a way that your battery is not affected. And if it is affected, we will see that in the third or fourth, and they still have 5 minutes to go out of the car. Yeah. 50 kilometers per hour. Yeah. I think Tushar has shown, or someone has shown today, that 62 kilometers per hour. That is like something that. But majority of the people do at 50 kilometers per hour. Earlier it was actually 30 kilometers per hour. Few years back. Can you imagine? Now they is to 50 kilometers per hour, but I don't think so. It will go beyond it in that direction.
Sir, we saw that aluminium is the future and it can be used for weight reduction, but the weldability of aluminium is low, so how are the fabrication challenges compensated for?
Yeah, it's a very interesting question. Weldability is always a problem with aluminium because of the oxide layer formed. So basically there are different methods. Why go for welding first when you can do hemming, when you can do joining, when you can do brazing solutions? So aluminium or maybe riveting. So aluminium is actually not really welded much. You can see that it is mainly done riveting. Lot of done is like adhesive bonding with the clay, with hemming, and also you will see a lot of brazing operations which are used for aluminium. Huh? Clinching, that's exactly basically riveting on the small side. Basically we call it riveting, and if you have a small rivets we call it clinching. Basically, so clinching is one of the very interesting method for the aluminium. So go for mechanical joining process, and that is also a very interesting question. How can you join basically aluminium with steel? It is not possible to weld this both material because it is not feasible. Aluminium is not a miscible. So we have to find a solution, because aluminium will not come 100% immediately. The steel will still be there. So there are very, very high chances that there will be many parts where aluminium and steel has to be joined. And aluminium has basically a potential higher than the steel. So who will corrode? The steel will start corroding. The negative potential will start corroding. It means immediately my tendency is, if I bring these two materials together, there is basically we are creating a battery inside that. We will have corrosion. So even on that perspective, we are trying to avoid the joining by bringing these two particles together. We are putting some inserts, we call it zinc inserts, which are put there in between them, and these zinc inserts are welded then together. So welding is done, but with inserts between the aluminium and steel. It's a very interesting question. Yes, exactly. You have to have some kind of, say, a blockage for the ion movement. Otherwise, the ions of the iron will go towards aluminium and will start corroding it. So because of that also one should, and that is also the problem with magnesium also. So these parts will have problem. CFK does not have that problem, so that's fine.
Hello, sir.
Yes.
Sir, I have heard that friction stir welding is also used in TBW. So there are certain issues welding magnesium with the dissimilar joining.
Right.
So is it true that TWB blanks are welded by FSW process?
Tailor welded blank are mainly done in steel with the laser welding. It is faster process, but yes, you are right. That is also possible with the friction stir welding, and it is also the process one can think. But the only problem is we are not having a straight line in tailor welded blank. Very rarely we would have a straight line. We would have really a curved line where to optimize the material, and there the friction stir welding becomes difficult, because you have to follow your rollers, everything in different contours. The laser welding becomes much faster. So majority of the OEM are preferring laser welding over friction stir welding.
And sir, one more question, that B plus section, differential heating is applied for toughness and strength combination. So what about the transition zone?
Yes, very interesting question. There we'll have the mixed properties, because we cannot avoid the transition zone. Like we are keeping it minimum. When I was writing this presentation, it was 20 millimeter. Now we have come down to 10 millimeter. But you can imagine controlling heat to that particular 10 millimeter extent is very, very impossible. And that has to be controlled. Otherwise, if I'm giving this 10 millimeter with plus minus 1 millimeter tolerance, it is a nightmare for the tooling makers, to see to it that we exactly get this property. So yes, you are right. In that area, we will have a transition, but it is not bad because we are going from soft zone to hard zone, but in a more transition form. It is an abrupt thing, and it is normally done in this way because.
Thank you, sir.
Yeah. Yes.
So regarding same what he has told, transition zone. Let's say I have given this design to CE people. Hello.
Yeah.
Let's say I have given this design to CE person. He has done the mesh of this part, and he now need to apply mechanical properties. So how he will apply? Like this is one part. Like if these are two different part, he will apply different properties and some joint in between.
Yes.
But
It
for
is-
this case,
This is a very good question because exactly that is a problem. The C people says they are putting still, I would say majority of the crash people are putting it a normal one property,
okay.
and that's why what we are getting really the crash worthiness simulation, not real to the simulation.
Real.
And this can be avoided. In fact, I have one slide about complete simulation part of it. I'm showing it. We have to go with the different material parameters. Otherwise, we will basically over-engineer our part. Because we will say that this part is breaking down because the softness is too high and those things, or it is completely part is very high strength and the down I don't need it. So, or maybe I would say the down I need more formability, and I would end up having more problems. So unfortunately, you are right. We are not able to use completely these processes in simulation at present, because we have to otherwise make this part into 3 different zones, give 3 different properties. That would be the best way. It is going to create difficulties, but we have done simulation and the total result is completely different. Reality is much better with that than if you would take a single part in that direction. So just wait for say 1 or 2 days and you will see the simulation where I will show you that what people were doing earlier and still doing it now and what we could do better, because we are doing so much in processes, but in simulation we are not able to get that advantage of it.
And one more question. You said about patches. So what is the material of patches?
The initial material the patches were used was basically taking the steel patches. Like nowadays we are using CFK as the patches, carbon fiber reinforced plastics. CFRP patches are there. So that we will see when we do CFRP. So what is happening? We are deforming the part, then we are putting that part again and using the same heat energy of the part to join the carbon fiber reinforced plastic with the original part, so that epoxy resin which is used will be used as an adhesive, and that will be cured together during the painting area. So during that, and it will get the complete strength. So majority of the patches which is done is by CFRP, the local patches.
Last question. I think it might be stupid.
No, it's nothing fine.
Let's say light weighting, we are doing light weighting of the cars. And as per conventional car, let's say it's a 50% less. Let's say strength is very good due to material technologies. And I am driving that car on the highways.